All right, good morning, y'all. Couple of things, just real quick. First and foremost, and I don't remember if I'm going to be there and have time to discuss this with you or not, but when I checked this morning at about 5 o'clock, there were still like 12 to 15 of you that had done 0% of your Delta Math from yesterday. 0%. So not even like, started. And then I checked into your actual amount of problems you've done, and there are some of you that have literally like tried one problem and got it wrong. So in an entire assignment, that was your attempt by 5 a.m. this morning from yesterday morning at the end of class. So that's not really going to fly. So I'm going to need y'all to do better than that because those grades are going to stand as of 8:30 this morning. Now, it would benefit you to still do that, considering the knowledge is what you need to be geared for. And I am going to go through some of that here at the end of the lesson, and I will most likely give you a partial grade for it being late once it is completed, because you do need to know how to do these kind of things. But 0% as of 5 o'clock this morning it's not really okay, y'all. So we need to do better. All right, so let's go into today's notes. You do need your unit circle. We can fill that in as we go. I'll just kind of have to talk you through that. I might can run print one real quick here in a minute once we get there, but I'm not going to do that right now. I'm going to go ahead and get started. So, all right. So basically today we're going to be talking about our trig functions of special angles. So these are the angles that are on your unit circle. All right, and you've done these triangles before in Math 2, your 30, 60, 90s, your 45, 45, 90s, okay? And they do have their sides. So there's a ratio of the sides in a 30, 60, 90. And you learned it, or at least when I used to teach Math 2 forever ago, there was cute little songs that went with this. But basically, 30, 60, 90 has sides that are in a ratio of 1 square root of 3 to 2. Okay? So if you label this triangle, 30 degrees is going to be our small angle, 60 is going to be our larger angle. Okay, and we've got our 90 degree right here. Now remember, the smallest side is always opposite the smallest angle. So whenever I'm looking at my ratio up here, the smallest side is 1. 2 being the largest side, so obviously 2 is going to be our hypotenuse. So then my smallest side, which is across from my smallest angle, is going to be 1. And then my longer side, or my middle of the 3, but my longer side of my legs is going to be square root 3. Okay, so that's just your ratio of your angles. And we used to talk about whenever we were doing 30, 60, 90 triangles, that twice the short leg was the hypotenuse. So in other words, if my short leg over here was 8, I could double that, and that would tell me my hypotenuse is 16. And then the short leg times the square root of 3 gives me the long leg. So if it was 8, it would be 8 square root of 3. But we don't do that as much here in pre-cal as we do knowing our unit circle and just these special angles and their values on the unit circle as far as their ordered pairs go. So then 45, 45, 90 is similar, except for its ratio is going to be 1 to 1 to square root of 2. And if y'all were to type in the square root of 2, you would notice it's a little bit more than 1. Same thing here. Square root of 3 is between 1 and 2. So 1 to 1 to square root of 2, okay, my hypotenuse is square root of 2, and these angles are equal. So then my two sides here are 1 and 1. Okay, so on the unit circle, this will be a radius of 2. This will be a radius of the square root of 2. All right, but we're going to relate that down here to the hypotenuse of 1, because with the hypotenuse of 1, we are in our unit circle. Okay, the radius is 1 in our unit circle, and our hypotenuse here is 1. Okay, so I'm going to do this. I'm going to show you the math around it. So if I need my hypotenuse here to be 1, and it was 2. So how do I get from 2 to 1? I'm going to divide by 2. But what you do to one side, we've got to do to all 3 to get our ratio. Okay? Let's see if I can turn my elbow a little bit here. All right, so that's going to give me 2 divided by 2 gives me 1. So we're good there. All right, and then I'm going to do 1 divided by 2 is going to give me 1/2. So we're good there. So this is my 30. We do have to label that, sorry. Okay, that's my 30, that's my 60. So 1/2. And then the square root of 3 divided by 2 is the square root of 3 divided by 2. So at this point, some of y'all should start thinking, should start recognizing that 1/2 and the square root of 3 over 2 are our special angle ordered pairs. All right, so we're going to do the same thing over here on the 45, 45, 90. So instead, if it's the square root of 2, to make 1, I've got to do the square root of 2 divided by the square root of 2, which does give me 1. But then for the other two sides, and I only have to do it once, but for the other two sides, I'm going to take 1 divided by the square root of 2. Well, remember, we cannot do that. This right here is part of the problem that y'all are having on that delta math, okay? But we cannot leave it here, so we are going to rationalize by doing our fancy 1. And our value here is going to be the square root of 2 over 2. And that is for both sides of a 45, 45, 90 with a radius of, or a hypotenuse of 1, which is our radius. Okay? All right, so we are going to walk through example number 1. And we'll talk about how this relates to the unit circle. And like I said, I'll run print out one here in a minute and fill it in with y'all. So we have all that done. Okay. All right. So graph theta in standard position and evaluate sine, cosine, and tangent for each value of theta. All right. So 60 degrees. We know 60 degrees in standard position is in quadrant 1. Okay, so when we look right back up above us, right to here, okay, we know our radius is 1, right? So we're going to drop our perpendicular and make our triangle. So when our radius is 1, we're just going to kind of flip this. So the bottom for us, everybody understand? Like you're basically kind of flipping this triangle to look like so in this quadrant, okay? All right, so if we flip that, that means our bottom down here is going to be 1/2, and our side, so this is our x value is 1/2, and our y value is the square root of 3 over 2. Okay, so that is the ordered pair. If I wanted this point right here, that is the ordered pair, 1/2 square root of 3 over 2. X being 1/2, y being the square root of 3 over 2. So now we're going to evaluate sine, cosine, and tangent of that. Now, if they give you 60 degrees, you could write 60 degrees here. They told me theta equals 60 degrees, so I can still put theta. Theta is a habit of mine, y'all. Sometimes I'll have to type over or write over or white out or whatever because I'll use it when I should not. But nonetheless, I can use it here since it is defined as 60 degrees. But again, you could put sine 60, cosine 60, and tangent 60 here as well. All right, so remember, sine we talked about is, you can do SOHCAHTOA, or we can know that sine, remember, is our y, cosine is our x. Okay, so if I do SOHCAHTOA, so I'll start at 60, so sine is opposite over hypotenuse. So opposite would be the square root of 3 over 2 over 1, which obviously is just the square root of 3 over 2. Cosine is adjacent, so 1/2 over 1, which is just 1/2. And then tangent would be opposite over adjacent. So I am going to work this out right here and show you. So opposite would be the square root of 3 over 2, and adjacent would be 1/2. Okay, y'all, if you do keep, change, flip, or whatever you did for multiplying fractions, I'll show you that. If you did, or dividing fractions, if you did the square root of 3 over 2 times 2 over 1, your 2's cancel, and you're just left with the square root of 3. Okay, which is our answer there. But also just understand, if you're ever dividing like this and your denominators are both the same, they just cancel each other out. So it'll be the square root of 3 over 1 regardless, which is the square root of 3. All right, let's move over here to letter B. All right, so here theta is 3 pi on 2. Okay, so 3 pi on 2, let me think about this. 3 pi on 2, if I talk about my unit circle. So this is 0 pi, pi on 2, pi, or 2 pi on 2. Okay, so 3 pi on 2 is the actual y-axis on the bottom half. Okay, so 3 pi on 2, down here, that ordered pair is 0, -1. So this angle's going all the way around to here, okay? Draw that in a different color for y'all. Okay, so there's our actual angle, all the way to there. Okay, so now we're going to do the sine of 3 pi on 2, the cosine of 3 pi on 2, and the tangent of 3 pi on 2. Okay, so remember, sine, I'll talk about it in both ways. Sine is either opposite over adjacent, or we can know that it's 3 pi on 2. It's our y value of 3 pi on 2. So if I do opposite over adjacent, right? Well, I don't really have a triangle here. Okay, because it is a vertical line. So I can't create a triangle here to do opposite over adjacent. So we're going to have to do x, y. All right, so sine we know is our y value. So sine here is going to be -1. Cosine's our x value, which is 0. And tangent is y over x. So tangent would be y, which is -1, over x, which is 0. But we have a 0 on the bottom, which makes our tangent here undefined. Okay. All right, so I'm going to pause real quick, go print me out a unit circle so that we can talk about that, and I'll be right back. All right, back to it. Okay, so I am going to go through example number 2 first. Okay, and then we'll jump to our unit circle. All right, so here we go. Example number 2, theta is 45 degrees. Okay, so that's obviously in quadrant 1. Boom. All right, and r equals 2. Okay, well, that's different. Okay, r equals 2, because before r was 1, which meant it made things just a little bit simpler. So let's talk about this. R equals 2. So drop our perpendicular. All right, 45 degrees, r equals 2. All right, well, I know the unit circle, you know, whatever, we can go from there, but we're going to talk about just the ratios in general. Remember, the ratios for 45, 45, 90 are 1 to 1 to square root of 2. Okay, so we're going to do the ratios here, or you could do Pythagorean theorem. I'll do it both ways just to show you. So if you did PT, right, you have the hypotenuse, and both sides are the same. Both angles are the same. So basically, both sides are going to be the same. So I could say x squared plus y squared equals 2 squared. Well, x and y are the same, so I'm going to replace that. Okay, so that's 2x squared equals 4. If I divide by 2, x equals 2, so x equals plus or minus the square root of 2. All right, and then we know it's in quadrant 1, so everything's positive, so x will be the square root of 2. Okay, and with the square root of 2 there. Now, if I did the ratios, so this is 2. All right, so how would I get the square root of 2 into a 2? I would multiply everything times the square root of 2. Okay, and then that would give me a 2. And then over here, this would give me the square root of 2 and the square root of 2. All right, so my two sides here is square root of 2, and then my hypotenuse is 2. So now if I want to do sine of 45, cosine of 45, and tangent of 45. Okay, so sine, again, is either your y or opposite over adjacent. But since our radius is 2, we can't do y. So we are going to have to do opposite over adjacent. So opposite here is going to be the square root of 2 over 2. Cosine's the same. Adjacent over hypotenuse is square root of 2 over 2. And then tangent we talked about was opposite. So that's going to be square root of 2 over the square root of 2, which is 1. Okay, so for 45 degrees, I got the square root of 2 over 2, square root of 2 over 2, and 1 when my radius was 2. Well, up here, I got the square root of 2 over 2, square root of 2 over 2, and 1 when my radius is 1. Okay, so this is what's key. If it is a special angle on your unit circle, no matter what your radius is, your ratio is always going to reduce down to those basic ordered pairs that we use. Okay? All right, so let's take... Okay, so right here, we're going to... Let's go ahead and fill in our unit circle. All right, so grab your unit circle. Let's go ahead and fill it in and get what we need to know. Okay, so remember, I don't have my original one with me. All right, so I'm going to try to fill that in as best I can real quick. So let's go 0 degrees, 30 degrees, 45, 60, 90. See, I already messed up. Got ahead of myself. Okay. All right, so y'all have already got your radians also on there. So this was 0 pi. All right, so let's go ahead. I'm gonna pause here for right now, and I'll complete filling mine in a second. Let's just get started on your ordered pairs. Okay, so remember, all right, right here, we're at 1, 0. All right, so for 30 degrees, remember for 30 degrees, so we'll do 60 real quick because we'd already done 60. So remember for 30 degrees at 60, we were at 1/2 square root of 3 over 2. So that's 1/2 square root of 3 over 2. For 45, we're at square root of 2 over 2, square root of 2 over 2. And then for 30, we're at the square root of 3 over 2 and 1/2. All right, so that's your main ones. And then up here, obviously, we're at 0, 1. Okay, so those are our main ones. And then basically, y'all, these are just going to flip per quadrant. Okay, so it should be like a mirror image, except for your signs are going to change. All right, so we can continue to fill that in. Like I said, I'm going to go back to our notes just because that's the purpose of the video. But we will continue to fill those in just basically. And what I mean by that, okay, is if you're looking here and you're at 120 degrees, right? So that's the same triangle. You don't need to draw these on your unit circle, okay? But that's going to be the same triangle as that. Okay, those are mirror images of each other. Okay, and this was a 60-degree angle here, right? So that meant this would be 30. So this is 60 and this will be 30. All right, so we're here. Okay, so our 1/2 is down here, but over here it's going to be negative 1/2 because in quadrant 2, okay, the only thing that is positive is sign. So negative 1/2 square root of 3 over 2. So then negative square root of 2 over 2, square root of 2 over 2, and negative square root of 3 over 2, 1/2, and then negative 1, 0. Okay, so then in quadrant 3, everything's negative. Quadrant 4, the sign or the y value is negative. Okay, so we can fill that in from there. You don't have to draw these ugly triangles in your answer. Okay, all right, so let's go back to example number 3. All right, so we are doing the theta is 60 and r equals 2. 60 degrees, I recognize is on my unit circle. Y'all need to start being able to do that to recognize it is on your unit circle. If it is on my unit circle, my R is irrelevant. Okay, my R is irrelevant. I can just use my ordered pair, 1/2 square root of 3 over 2 to evaluate my functions. Okay, so for sine, I need to do sine. All 6, doesn't it? Oh, wow, all 6. Okay, so sine 60 or theta, cosine 60, tangent 60, and then cosecant 60, secant 60, and cotangent 60. All right, so sine is y, cosine is x, so let's just fill those straight in, y'all. Sine is y, so that's going to be square root of 3 over 2. Cosine is x, that's going to be 1/2. All right, so remember, tangent is y over x. I'll write it out over here, but we're going to start figuring out these things and starting to learn these values without having to calculate it. Also, do not ever give me decimal values for any of your special angle measurements. Nothing, okay? I understand, like, you'll get to learn, you should, if you're trying to use the calculator too much, you'll start to learn that the square root of 3 over 2 is 0.866, and the square root of 2 over 2 is 0.707. Okay, those are ours, but don't ever give me those decimal values. You need to put it in this term. Okay, so again, I'll do the calculation here. So y over x, or sine over cosine, so the square root of 3 over 2 over 1/2. The 2's again cancel out, so I'm just left with the square root of 3 for tangent. All right, so remember, cosecant basically flips it upside down. So that's going to give me 2 over the square root of 3. Well, warning, we can't have that. So we're going to have to multiply by our fancy 1, making our answer 2 square root of 3 over 3. Secant, just flip 1 over 2, it becomes 2. And then cotangent would become, because remember this is over 1, so cotangent would become 1 over the square root of 3. Again, we can't have that, so it's the square root of 3 over 3. Okay? All right, let's go over here to 5 pi on 6. Well, again, I've not filled in everything on my unit circle, but y'all have more filled in than I do. So 5 pi on 6 is going to be right here. Okay, 5 pi on 6, negative square root of 3 over 2, and 1/2. 5 pi on 6 is negative square root of 3 over 2, and 1/2. Okay, so here we go. Let's just figure it out. So sine, cosine, tangent. I'm going to do those first real quick. So sine is y, so that's 1/2. Cosine is x, negative square root of 3 over 2. And tangent is y over x. So now again, that's going to become 1/2 over negative square root of 3 over 2. So I end up with 1 over negative square root of 3. We can't have that. So it's going to be negative square root of 3 over 3. All right, and then the other side of that was cosecant, secant, and cotangent. All right, so cosecant is just going to be, flip the 1 over 2 becomes 2 over 1. Secant, you're going to flip it. Okay, but again, we can't have that square root of 3 in the denominator, so I'm just going to go ahead and know that's going to be, the 2's on top, so that's negative 2. If I'm trying to rationalize the denominator, I've got to multiply the top and bottom by the square root of 3, so it's going to be negative 2 square root of 3 over 3. And then same thing here, but if you remember, before I rationalized this, I had 1 over the negative square root of 3. So just flip that upside down, it's going to be the negative square root of 3. All right. Example number 4 is kind of a throwback example. Zoom out a little, try to zoom out a little bit, maybe. Okay, throwback example. Trying to just find standard position here. Okay. Oh, it's not. My bad, y'all. That's why. Okay. So it's 250 degrees in standard position. Okay. Means we want to find the reference angle of that. So remember, reference angles are between 0 and 90, or 0 and pi on 2. Okay. So 250 degrees is technically in quadrant 3. Okay, so the quickest way to get back up to X is going to be, this is 180 and this is 250. So what is the distance from 180 to 250? And that is, in fact, 70. So the short way to do that, remember, is you could just do 250 minus 180, and it is 70 degrees. All right, 5 pi on 6 is over here in quadrant 2. Okay, so this is pi. So what's the quickest way? What's the distance between 5 pi on 6 and pi? So what do we need to do to get from 5 pi on 6 to pi? Remember, pi is 6 pi on 6 and 5 pi on 6. So if we subtract that, it is pi on 6. All right. 19 pi on 12. Okay, well, I'm not really sure where that is. So let's try to think about this. If we're in 12s, right? So this will be 12 pi on 12. This will be 24 pi on 12. And right between 12 and 24 would be 18 pi on 12. So 19 is over here in quadrant 4. So then we're going to do 24 minus 19. And that's going to give me 5 pi on 12 as my reference angle. All right, and then D is negative 120. So just means that goes clockwise. So negative 120 is going to be over here. And again, the quickest way is to go right up. And the distance from 180 to 120 is going to be 60. Okay, our reference angle is not negative. All right, and they did ask us to label these as theta prime, y'all. So really you could put theta prime equals on all of these. Okay. All right. Example number 5. All right, evaluate sine, cosine, and tangent for each of the following. Okay, so 240. 240 is on our unit circle. I'm going to recognize that. It's going to be in quadrant 3 down there. And our ordered pair should be some type of 1/2 square root of 3 over 2. Okay, so you can look at your unit circle and tell me at 240, okay, we should be in quadrant 3, so everything's negative. So negative 1/2, negative square root of 3 over 2. All right, so let's fill it in. Sine, cosine, and tangent. Sine is our x. Sine is our y. Cosine is our x. And tangent is y over x. So remember, basically these two on top of each other. 2's are going to cancel, negatives are going to cancel, and our tangent is going to be positive square root of 3. Okay, y'all remember back to our, and we'll use this as an example of 6 here in a second, but all students take calculus. So in quadrant, where are we at? 3, tangent is the only thing that is positive. And if you notice, tangent is the only thing that is positive. All right, so for 495, we're not in standard position. Okay, so I'm going to subtract my 360 to get me in standard position. And when I do that, I get 135. And I know 135 is a special angle. It's in quadrant 2. It's my 45-45 angle in quadrant 2. So in quadrant 2, my ordered pair is negative x, positive y. So now we can go sine, cosine, tangent. So in quadrant 2, y is positive, x is negative, and then tangent is going to be the ratio of those, which is the same thing. It's going to be a 1, and it's going to be a negative 1. All right. Now, 33 pi on 18. So one thing I notice here is 18 is not one of my special denominators on my unit circle. My unit circle denominators are obviously 1, 2, 3, 4, and 6. But I do notice that I can reduce this fraction down. And I'm going to reduce it down to 11 pi on 6, which then I am going to notice is in my unit circle. It is my technically 330 degrees, 11 pi on 6 in quadrant 4. So in quadrant 4, it's going to be the square root of 3 over 2 negative, positive square root of 2, negative 1/2, sorry. Okay? So X is positive, Y is negative. So here we go. Sine, cosine. All right, and tangent. So sine over cosine. All right, well, that gives me -1 over the square root of 3, which we can't have, so we have to do our fancy 1. So it's going to be the negative square root of 3 over 3. All right, last example on here. We're going to talk about your delta math real quick. And then y'all do need to finish filling in your unit circle. All right, so example number 6. If theta is between 0 and 360 degrees, so just one unit circle rotation. All right, find all values of theta for which tangent is -1. All right, well, let's go back to what we talked about in the notes yesterday about my little reference figure, right? Where I said all students take calculus, correct? And remember, these are the things that are positive. So in quadrant 1, everything's positive. In quadrant 2, sine is positive, 3, tangent is positive, and 4, cosine is positive. So if it's asking where is the tangent -1, tangent's positive in 1 and 3, therefore tangent is negative in 2 and 4. Okay, so tangent is negative in 2 and 4. All right, and then they wanted to equal 1. Well, the only way for us to equal 1, because remember, tangent is sine over cosine, right? So the only way for this to equal 1 at all is for it to be the same. And what angle has the same measurement on both sine and cosine? And that's our 45-degree angle in each quadrant. So in quadrant 2, in quadrant 2 over here, so 45, that's going to be the 135-degree angle. And then in quadrant 4, that's going to be the 315-degree angle. All right? Okay, so all of that goes through. Now, make sure, again, that you fill in your unit circle. All right, fill in your unit circle completely. You do have a unit circle quiz next week. Remember, you are out of school for this. I don't know how long I use this video, so I'm going to say 2024. Okay, in 2024, you're out of school on Monday and Tuesday of next week. Okay, so you come back to school on Wednesday. All right, and you do have a unit regular test 5 quiz on lessons 1, 2, 3, and I think 4 on Wednesday. Okay, and then your unit circle quiz will probably be Friday. All right, so let's look at that delta math. Whew, children. I don't even think I have paper. All right, we're going to improvise. Okay. I'm not at my actual desk in my classroom, so I don't have paper. All right, so I'm going to go real quick and just pull up a couple of these. I got to write them down so I can come back and show you the work. All right, so right here. All right, first one. Identifying trig ratios. Let me see. Okay, so this is the first problem. I'm going to copy it down. All right, so let me draw this lovely triangle out. All right. All right. I, H, and J. Okay, so if you're done with your delta math and you're not really focusing too much on this, but again, there's more than half of you pretty much that aren't. All right, what did it ask me for? Sorry. Cosine of H. Okay, so we're using SOHCAHTOA here. Okay, cosine of H. So first of all, you got to identify H. H is here. So if this is H, this is the opposite, this is the adjacent, and this is always your hypotenuse. Okay, because it's across from the 90-degree angle. All right, so cosine of H. Cosine is adjacent over hypotenuse. All right, so adjacent to h is the square root of 87 over 12. All right, now your calculator will do radicals for you real quick. Okay, so if you go to y equals and you plug in whatever number you need, 87 divided by x squared, and you look at your second graph, so look at your table, you're going to notice there are no whole numbers. So really 0 is where you want to start. Okay, you're going to notice there's no whole numbers over here. So 87 doesn't break down. That is your answer. Okay, now I'm not naive enough to think that's the one y'all would have a hard time with. So let me go back and do a different one. Okay, sine of C. All right, sine of C, and we've got 5, 4, and the square root of 41. Okay, and this was the sine of C. I'm going to write a couple of these down real quick. All right, tangent of I. All right, this is the other one I'm going to do here. Okay, so let me go back. Now I forgot on the second one, on the sine of C, I don't know which one was which, so we're just going to make it A, B, and C. I don't know. It doesn't matter. All right, so sine of C, here's C. Sine is opposite over hypotenuse, so that's going to be 5 over the square root of 41. Well, remember, we can't do that, so 41 goes on top and bottom, so the sine of C is going to equal 5 square root of 41 over 41. 41 is prime, so you're done. All right, and the same thing here. We were doing the tangent here of I. So here's I. So tangent is opposite over adjacent. So that's going to be 4 over the square root of 31. And we rationalize that. And it's going to be 4 square root of 31 over 31. All right, that's the first section. Okay. All right, let's look at the second section. All right, cosine of A in simplest radical form. So here's where the simplest radical form is what really threw some of y'all. All right, so the square root of 63 over and 9 and 12, and we are B, C, A, and we want to find the cosine of A. All right, so ultimately, y'all, I'm not going to do many of these, but basically you need to know how to break down radicals and simplify. So cosine of A, so here's A, cosine is adjacent over hypotenuse. I'm going to do all of them here just to show you, okay, because adjacent is 9. 9 over 12 is going to reduce down to 3/4, and you're done. So let's say we did the sine of A. So that's opposite over hypotenuse. So that's going to be the square root of 63 over 12. But 63 can break down. I know what 63 can break down into, okay? But you may not. So if you go in here and you do 63, and then second table, you're going to see 63 is the same thing as 3 on the outside, 7 on the inside. Okay, so now I've got 3 square root of 7 over 12, which reduces down to the square root of 7 over 4. Okay. All right, let's try this one. Sine of A. Okay, so here's A. All right, sine of A. All right, so sine again is opposite over hypotenuse, so that's going to be 7 over the square root of 85. All right, which we know we can't leave that there. So that's going to give me 7 square root of 85 over 85. Well, can 85 break down at all? Let's see. It does not, so we're done. However, if it did, okay, so here's where a lot of y'all were coming into the issue whenever I was asked about it. I don't remember if it was first or third, okay? Let's say y'all had like 4 square root of 50 over 6. It doesn't matter, okay? Now understand this is just a random made up situation, okay? So we know that 50 breaks down into 5 square root of 2. So then that will be 4 times 5 square root of 2 over 6. 4 times 5 is going to be 20 square root of 2 over 6. Okay, but then you've still got to reduce this. 20 over 6 does reduce down to 10 over 3. So it'll be 10 square root of 2 over 3. That is what they mean by simplest radical form, y'all. Break down your radical, okay, and then reduce your fraction. All right, and the last one here that we had. Okay, so if you're given the other side, remember all we're doing is labeling that triangle. So given tangent of A equals 6 over 5 in quadrant 1. Hopefully I can remember that. Tangent of A equals 6 over 5 in quadrant 1. Okay, so let's draw that out. Quadrant 1, there's my reference triangle. So tangent is opposite over adjacent, right? So opposite's going to be 6, adjacent's going to be 5. And we're going to PT this. So 6 squared plus 5 squared. So the square root of 61. Okay, and then from there it's asking you to find secant in simplest radical form, rational denominator, meaning we cannot have that radical down there. So secant, remember, is 1 over cosine. So we're going to do cosine first. All right, so cosine would be adjacent over hypotenuse, so 5 over the square root of 61. Okay, so secant just flips that, y'all. You could either just do the square root of 61 over 5, or you could rationalize and then reduce at the end. All right, hopefully that helps. Make sure you get your worksheet done in class today. Make sure if you've not done your Delta Math that you get that done as well. And I will see you all, well, I'll see you at the homecoming pep rally, hopefully, because I will be back today. But I will see you all Wednesday. Enjoy your long weekend if I don't see you before then.